Good morning, everybody. Welcome. Oh, let me tilt this down just a little bit. There we go. Good morning, everybody. Welcome to math class. I'm Mr. Taco. As always, up here is our title of the day. We're going to be answering this question of what is a fraction? Okay, over here, those are all the things you're going to need today. Something to write on, something to write with. We don't need any special tools today. We're going to keep this one short and sweet, hopefully, just reviewing this idea of what is a fraction. And then down here, there's our I cans. I can follow a lesson on YouTube. I can identify the value of a given fraction. And additionally, we're going to be reviewing our definitions of two words today. Those words are numerator and denominator. Let's get into it. So this idea of what is a fraction can be kind of a tricky one. At its heart, fractions are, in essence, division. You're taking a quantity, an amount of something with value, numerical value, and you're splitting it into equal parts. In essence, that's what division is, okay? When you're, say, doing 20 divided by 5, for instance, which if we know our smaller multiplication division facts, we know the answer is 4. 20 divided by 5 equals 4. In essence, what we're doing is we're taking that 20, whatever this numerical value of 20 is, we're splitting it into 5 equal parts, or we're making fifths, okay? And the value of each one of those fifths is 4, okay? You can make a fraction out of any value. For streamlining these things, what we're going to be talking about today are fractions of 1. So anytime you see these, either a fraction bar or a round like a pizza pie, we're going to be thinking about the value of all of these models today is going to be 1. So we're going to be splitting that one thing up into equal parts. Make sense? So again, when we think about, and when I'm drawing fractions, we're going to use equal in kind of a loose sense because I'm, for time's sake, I'm not getting out a ruler and I'm not exactly measuring every single fraction to make sure that each of my parts is equal. We're going to be equal-ish for fractions, for a lot of fractions. So I just want to remind about that, okay? The idea of fractions, again, is division. It's dividing something into equal parts, okay? So if I split something into 2 equal parts, right, the same amount, I can already tell that I'm just looking at that rectangle that it's not mathematically equal, but we're going to say those are equal because getting a ruler takes time. And again, I want to keep it short and sweet. When we talk about splitting something into equal parts and making a fraction, okay, we want to keep track of what's the size of our part in relation to the whole number. Okay, in this case, it's 1, and we've made 2 halves. Okay, we've split our one whole fraction bar into 2 halves. That's our name for dividing something into 2 equal pieces, is cutting it in half. Right? If we wanted to divide it into 3 equal pieces, we'd be in thirds. Right? If we wanted to divide something into 4 equal pieces, we'd have fourths or quarters. And what fractions are able to do really, really nicely is no matter what value you have, this fraction bar behind me, that could equal 1, that could equal 2, that could equal 5, that could equal 20, that could equal 1,000,000. And as long as you're saying, well, that's divided into thirds, we know that there are 3 equal parts that you've divided that value into. So fractions are actually really great because they work with any value of something, right? Whether you're cutting 1 pizza or 2 pizzas or 10 pizzas or 1,000,000 pizzas, right? A third of 1,000,000 is the same relationship to the whole number, the whole thing, as a third of 1. it means you've cut whatever value you have into 3 equal parts. Down here into 4 equal parts, right? And we're talking about, if we're talking about 1/4, we're talking about one of these parts. Okay? The relationship between fractions and division is so apparent. If you take a look at the division sign, oh my gosh, it's actually a fraction. That's why we use the division sign. There's a line in the middle, there's a thing on top, there's a thing on the bottom. All right? When we talk about fractions and we want to use our mathematical academic vocabulary, there's 2 parts to a fraction. On top is the numerator. That's how many pieces we're talking about. The bottom is the denominator. That's the size of the piece. How many equal pieces did you cut our quantity, our value, our numerical value into? Okay, so if we go back to our fraction bar and our fraction round, and I were to shade in some of our fraction, not some of our whole number. So maybe we can do that, right? Because that's the bit we want to talk about. So we want to think about how many pieces, how many equal pieces did we cut this whole thing into? And then how many parts are we dealing with? How many parts are we shaded in? Right? So there are three equal parts that we divided this fraction bar into. And we're looking at, or we're dealing with, or we're shading in 2 of them. So we can say that this fraction has a value of 2/3. Okay? In this case, it's 2/3 of 1. If it were a larger quantity, let's say 2/3 of 6, right? What would 2/3 of 6 be? If this whole thing were equal to 6, we split 6 into 3 equal parts. 3 times what is 6? 2. So each of these parts, 2 plus 2 plus 2, makes 6, right? And if we're dealing with 2 of those thirds, we have 2 plus 2 equals 4. Okay, so 2/3 of 6, or 2/3 times 6, would be 4. We're getting a little ahead of ourselves. Let's think about another one. What if I shaded in this bit in our fraction round? Okay, what would be our numerator in this case? How many pieces did I shade in? And what would be the denominator? What is the size of the piece? How many equal parts did I divide my whole into? Give you a second to think about it. You are correct. We've got 1 part shaded in, that's our numerator. That's the section of the fraction we want to deal with, or we want to know. And then the whole thing is divided into 4 equal parts. So this would be a representation of 1/4. All right, let's move from our real life whiteboard to our digital whiteboard here. And let's take a look at a couple different examples and models. So here, let's start with this first one. Oh, where'd it go? There it is. So here, let's think about what's our denominator. So already looking, what's our denominator here? Count your equal parts. Okay. No matter what value our whole fraction bar is, we've divided this into 4 equal parts, right? And then what's our numerator? What are we going to be focusing on here? I'm going to change my color of my pen so you can still see the lines. If I were to do that, what would be the value of our fraction? What would be the numerator there? Okay, right, since we shaded in 3 of those pieces, we're dealing with 3/4. This is what this shows. If we were to shade in that last one, we'd have what? 4/4, which is another way of saying that's the whole thing, right? When your numerator and your denominator match, that is equal to 1 whole. Okay? Let's try one more. I'm going to shade it in, and then you are going to tell me the numerator and the denominator here. Okay. So with this one, what number would go on top? Our numerator, the number of pieces that we're dealing with, and what number would go on the bottom? Our denominator, our total number of equal parts our whole is divided into. Okay, so let's look at our numerator on top. We've got 1, 2, 3, 4. And then often what I will see from emerging mathematicians is they'll go, oh, there's 4 parts on top, and then there's 3 that aren't shaded. That tells us some information, but remember, our denominator is our total number of equal parts we're dividing that value or that whole into. Okay, so we have 1, 2, 3, 4, 5, 6, and 7. So this model is showing 4/7. Okay, the more comfortable we are with that idea of the numerator being the number of pieces we're looking at or dealing with, and the denominator being the total number of equal pieces we've divided our whole into, the more smoothly we're going to be able to use all 4 operations with fractions. Okay, and thinking about that concept of if I have 3/4 and I'm adding another 3/4 to it, what's my total value in relation to the whole, right? And that's where the denominator comes into play, because in order to add something, you've got to have a common size or a common value to your piece so you can add it, right? It's impossible or very, very difficult to add or subtract things when you don't know actually how much they're worth, right? So with 3/4 plus 3/4, we know how much each piece is worth because of that denominator. And then we can just add the numerators together to get 6/4. That'll be tomorrow's lesson. We'll get there. Thank you for tuning in, everybody. I really, really appreciate you coming. I see currently 16 of you. That's a little less than our class total. I bet a lot of you are going to pick it up later, I'm going to assume. Exit ticket is on Google Classroom. Good luck with that. It's due at noon, and then we will be back here tomorrow at 10:30 to talk about how to add fractions with like denominators, another review lesson for us. All right, thanks for tuning in, everybody. We will see you next time.